Hi everyone, this video is going to take a look at global population and its density. As you remember from the first chapter, we briefly looked at the idea of density and distribution in terms of the different aspects of density or of distribution, and one of them was density. So we started looking at the three specific ways we can describe density in terms of arithmetic, physiological, and agricultural. So when looking at world population density, we have to consider this from a spatial perspective because it changes drastically depending on the type of density we're looking at. And again, looking at arithmetic density, we're simply taking the population divided by the square miles of land, or the units of land that we're using. So if we use square kilometers as well. But you can see that, you know, looking spatially at it, we see your eyes are attracted towards especially parts of Asia, East Asia, South Asia, you know, as being primary areas where you see arithmetic density. If we just change that just a little bit and look at physiological density, we see a different distribution pattern. You know, we still see areas of China being represented in terms of the physiological density, but India, it changes, and we see other countries throughout the world starting to be represented with higher concentrations or densities in those areas. And so physiological density simply just looks at the amount of arable land instead of overall land, what is actually usable for agriculture to support a population. You know, what characteristics support that population, and you see that changes drastically. So a country like Egypt, there's a lot of people, but very little of the land of Egypt is actually arable or useful for supporting human population. Most of it is consumed by the Sahara Desert. But along that narrow band of land that's useful along the Nile River, it can support a massive population. So physiological density is very high in Egypt, but the arithmetic density isn't necessarily. So a good example there to highlight the usable land as a feature of physiological density. Agricultural density looks at the farmers per square mile or unit of arable land. And again, you see a different pattern and distribution throughout the world based on this. And this one, not only does it look at what people are doing, but this starts to look at economic development. You'll notice in places in Africa, as a general statement, Africa is one of the poorer regions of the world. And if you look at the type of economic activity that occurs there, that the number of subsistence agriculture, people conducting subsistence agriculture, supporting themselves, is very high. And so a country like Guinea has an 80% of the population is in agriculture. And so the agricultural density, the farmers per unit, are very high. That you could carry that out into the types of capital that's being used in farming, among other things that we could look at. When we factor these ideas of density together and just look at pure population growth over time, you can see that there's a drastic change in the middle of the second millennium CE, or AD on this particular representation. The question to be asking is why? What happened? We can obviously look at this, and population growth is exponential, but what happened in the middle part of the second millennium, or around 1800? And the answer to that question would be the Industrial Revolution, and we'll look at that impact more moving forward. And so if we look at just the doubling time, or the additional billions, as we move towards over 7 billion people, we can see that rate of growth is changing drastically. Going from 1 to 2 billion took over a century, yet recently, if we look at in the last 15 years, we've grown significantly. In the last 30 years, we've added 2 more billion people. So we look at natural rate of increase as a way of determining where is the population growing the fastest. And if you look, it's very clear where that's taking place. And if we start asking economic questions or asking social questions, what is it that makes those rates higher in places like Africa? And we could look at different areas. Another way of representing population is to simply take land area and look at where that population fits in. So we can remember, if you remember where countries had big populations, where would they be located now by just land area? So questions we might start asking is, are we running out of space? Do we have enough? Are we overpopulated? And how much do we actually take up? If we gave everyone an 1,100 square foot home, the world population would only take up the size of the state of Texas. There you go. Theoretically, though, we could take up the size of Melville Island if we were just giving 9 square feet, 3 by 3 square. The population would fit on this northern island, Melville Island. How does that work? All the space in the world, how does this support? Why do we talk about overpopulation? And we're going to start looking at those resource issues as represented by Thomas Malthus, which is your reading assignment for today.